Okay, so this is section 5.4, applying properties of definite integrals. Sorry about all the crazy numbers, 6.6, less than 4. We're just going to call this 5.4. We're now going to be introduced to the Leibniz symbols for integral and definite integral notation, and we're also going to be dealing with negative area. Negative area is area that goes below the x-axis. Those are negatives. Okay. Hopefully you've downloaded this guided worksheet, and we're just going to work it out together and fill it in. Okay. So first thing first, let's just understand how to read this notation. And it's pretty easy. It's the definite integral from a to b of f of x with respect to x. Okay, so to kind of take that apart, you have the components, and let's list out what these are. This is a, which is your lower limit, and b obviously is your upper limit. I should introduce you to this symbol. We've used it before, but this is your integral. That's the actual symbol for the integral, okay? And the function that is next to it is actually your integrand. That's what we call it. It is a derivative, surprisingly enough. And dx represents the variable of the integration, which in this case is x. It could be du, it could be dy, but this is known as your definite integral. Okay? And so the definite integral can be used to determine what we call net area. Net area. Okay, so write this down. The net area, or the displacement, bounded by the x-axis, the function f of x, and the vertical lines x equals a to x equals b. That's what that means. Crazy. Means a lot of different things, but it basically is area under a curve. We've done that before. All right, so turn to your next page. And we're actually going to see if we can do some of this ourselves. Use the graph below to evaluate each of the following. Note that the graph of f of x consists entirely of line segments and a semicircle on the interval from -8 to 13. And I believe that's wrong. And a semicircle on the interval from, oh, you're from -8 to 13. Sorry, not just the negative semicircle. All right, so you know your basic area formulas. If you have area formulas, if you have half a circle, that would be half pi r squared. And if you have a, well, this we could probably draw into a triangle. That's half times base times height. And trapezoid, I mean, you can make it into two triangles and then a rectangle, but honestly, you should know the trapezoid formula, which is half times height times base 1 plus base 2. Good old geometry. So let's try to answer some of these together then and see what they're talking about. So this first one, A, the integral from 0 to 7 of the function, from just 0 to 7. Okay, so come with me and let's look at 0 to 7. Well, that looks like this trapezoid right here. Okay. And to find the area for a trapezoid, I do half times the height, which would be 1, 2, 3, 4, times base 1 and base 2. Those are your parallel sides. So base 1 and base 2 would be, let's see, this would be obviously 7 plus this up here would be 3. So that has an area of 20. So all of this right here has an area of 20. All right, let's do another one. Let's do B. The area from 0 to 13 of the function. Ooh, okay, well, what does that mean now? Well, not only do I have this area, but I also am including this area. So I want area 20, and I'm going to subtract from this. Or another way to think about it is anything under the x-axis is negative. So why don't I just find the area of from 7 to 13? So that area would be 1/2 times the height, which would be 3. This has a height of 3. This base is 6, and this base is 3. So times 6 plus 3. Half times 3 times 6 plus 3 is, why can't I think right now? 27 over 2. And then you're just going to subtract that. Oops, 6 plus 3. And you would get 6.5. Okay. Again, you could have thought of this as 5. Because 20 minus the 13.5 is 6.5. All right. Moving on to part C. What would be the area from -6 to 0? Again, -6 to 0 is under the x-axis. It is a semicircle. Semicircles are half pi r squared. So what is my radius here? My radius is 3 pi r squared. So 9 times a half times pi, or 9/2 pi. But again, I'm underneath the axis, so it'd be negative 9/2 pi. All right, and then what about the integrand from 3 to 3 of the function? How would I do that? Integrand from 3 to 3 of the function. If I go from 3 to 3, have I actually done any area, anything there? No, it's 0. Easy peasy. All right, how about from 7 to 0? That seems weird. It always seemed like everything on the bottom was our lower bound and this one on the top was our upper bound. Now we've switched that. So what do you think is going to happen there? Well, just like you've suspected, instead of going from 0 to 7, you're going to 7 to 0. This 20 would actually just be -20. Okay, these are properties we're going to find out that always occur. So then what about f? It goes from 10 to 4 of the function. 10 to 4. Well, if I just flip-flop a and b and it switches the sign, that's what I'm going to do here. I'm going to say if I take out a negative, then I can flip-flop a and b. So let's see what that would be. We're now going from 4 to 10. So we are actually going from here to 10, which is here. Interesting. So we've got a positive area and then under an axis, a negative area. Okay. So this would be, figure out this area right up in here. This would be an area of, again, this is a trapezoid, half times the height, which is 4, times base 1 and base 2. So half of 4 and 1 plus 3. So half of 4 times 4, or half of 16, which is 8. That's my upper region. My bottom region right here would be 1/2. The height is 3. And then the one base is 3 and the other base is 2. So 3 plus 2 make 5. Half of 3 times 5 is half of 15, which is 7.5. So we are going to minus 7.5. And don't forget, we pulled out this negative out here because that we had it backwards, the A and the B. So my final answer is negative 1/2. All right, moving on. I'm just probably going to do this this last one and maybe answer the true and false. What would be the area from -8 all the way to 13 then of the whole entire function? Well, the only thing I really haven't found area for is this little triangle piece right here. Let me find that area for this real quick. So that's a triangle. That would be 1/2 times the base, which is 2, times the height, which is 4. So half of 4 times 2 is 4. Okay, so this is 4. And then I'm just going to add it to this right here, which we found to be -9/2. 9 pi over 2, I should say. Then I'm going to add it to this entire red region, which we found to be 20. And then I'm going to add it to this entire purple region, even though it was blue, which we found to be, did we find that one? 0 to 13. No, we actually didn't find that one. So that would be half of 3 times the base, which is 3, plus 6. Okay, and all of that, you just add it together, and you would get 10.5 minus 9 pi over 2. I'm not going to figure that out as a decimal, but I think you get my drift. Okay, look at K real quick. True or false? The integral from 0 to 2 of f of x dx plus the integral from 2 to 4 of f of x dx. Would that be the same as 0 to 4 of f of x dx? What do you think? True or false? Take a minute. Got a 50-50 shot. That's true. It's true.